I invite Mr. Rajesh Lande from.
Happy morning, everyone. Myself, Rajesh Lande from Dalmia Group. I'm representing Dalmia, and I'm very much thankful to the ARC and Knowledge Lens team who had given me an opportunity to give us some insights how in Dalmia Group we have implemented digital tool to improve our manufacturing productivity and other key aspects. So, just going through the slides, as far as this business aspect concept, for any of the business, the key focus area of organization to improve the productivity and get the optimized investment and get the the manpower who are associated with the manufacturing. We have to take a safety and make a work and his personal life balance. So we had implemented a digital tool into our group plants in the manufacturing of cement, manufacturing other manufacturing processes in power generations, wasted power generations, and renewable power generations. And we have also focused on the sustainability part as well to optimize fossil fuel consumptions reduction, then introduce so many alternate fuels into our process operations, then using our power consumptions and replacing our power consumptions by renewable sources like solar powers, wind powers, and wasted recovery powers. So, we had initiated this digital transformation in our business by improving productivity, by taking a key focus area of to improve the productivity and reduce the risk into the manufacturing. These are the smart manufacturing tools we have focused on. In the manufacturing, whatever assets we are managing, that how we can predictively manage that, how we can utilize and optimize to use those assets and avoid our unplanned downtimes. In the process controls and managements, we have our main key focus area to improve our productivity with the quality and how we can contribute towards the sustainability into the process control and process manufacturing part. One key focus area is the energy management. Nowadays, in every industries, they have a very pain area and the energy because those are contributing a very costly part, fuel and energy into the production of any of the process. Next is this safety management. We are closely monitoring our safety of human as well as machineries with the implementing a digital tool. Of course, this production simulation and all those things by using this artificial intelligence, machine learnings, and digital tools. We have also implemented all our group plants. And as our OEMs, ABB, Siemens, and other OEMs, those who have given us the technology for operations of cement plants, they have a good latest technology implemented in our cement plants, but we feel that over and above their technology for production or process simulation, there is a need to superimpose some digital tools to specifically customize our particular process, because if in Dalmia Group we have a pan-India based plants, all plants, raw material, raw mix, their fossil fuel and their alternate fuels, they have a different chemical compositions. So we have to prepare our process simulation in such a way that so that that particular process should be efficiently performed and give us a result. So that we had done along with our this digital tool implementation of knowledge lens. We precisely done a work upon it, and we get a good result of any of the individual process. Definitely this supply chain planning is also one of the key process area, and these are the very continuous process to forecast our coming demands, productions, and all those things, and we have to precisely plan those things that could give us a very good help into the supply chain planning. So this is the same, the business operations and business growth. What are the key objectives of our organization? To improve productivity, reduce risk, add incremental revenues, and generate a new revenues from the manufacturing. These are the key organization, any of the organization focus area. So we have utilized this digital tool to contribute into this organization to achieve a key focus goals of the organizations. These are the focus area we talked about, like first people. So those who are associated directly, indirectly with our manufacturing, we are focusing on their all work culture, their work and personal life balance, their safeties, and giving us all these things into in a very planned way to give their good efficient output. Next process, definitely this process we had so many other solutions also with our automations. We implemented into our process operations. So we have, with the digital tool, we have integrated all those subsystems into a single platform and very closely monitoring the things in a totality and getting a good result out of it. Definitely this sustainability is everyone's aim to contribute into the sustainability. We have to explore as optimize the earth resources during our manufacturing. So we have introduced alternate fuels, different alternate fuels into our system operations. Utility and energy we have worked upon. Then definitely these raw materials, raw mix, and all those things. So how we have implemented the digital tool into our manufacturing process? These are the analysis KPIs we have derived. Means we have worked out for any of the particular process. We selected some KPIs, main KPIs, which we had given a priority 1, and we have segregated further KPIs in priority 2, priority 3, priority 4, and we have made a mathematical model in such a way that so that the main KPIs, how it will be correlate with the priority 2, priority 3 and other KPIs, and what will be the contribution of those KPIs will resulting a KPI 1 should achieve in a target way. So this way we have worked it out all the KPIs on our any of the particular process, and we have framed out into the digital tools. Then this yield optimization, raw material uses optimization, all these are part of this process, manufacturing process, and we have taken into the consideration. This energy loss is one of the key area. Fuel consumption is one of the key area. We introduce renewable energy into the system to curtail down our energy cost into the system, and we can contribute towards the sustainability and renewable power. Dalmia is a RE 100 placed company, and we have targeted to achieve our all power requirements to be converted into the renewable power in 2040. So we had already initiated actions to implement a renewable power, solar, wind, and other wasted recovery powers into the system. And till FY23, we had already converted our conventional power by 26% into the renewable power. And our way is moving forward to the direction as per our target to become a RE100 till 2040. So these asset efficiency and all those things that we had related along with our associate partner of Knowledge Lens and SAP, HANA, the asset management tools, we have done a centralized asset management solution. So all assets which we had, whatever inventories we have centrally displayed to all our pan-India plants users. So they can monitor the inventories, what they require, what are the assets other plants are maintaining, and how they are controlling or taking a quick action to get a efficient assets operations and all those things. So with the help of digital tools, we could be transparently sharing with all our group plants users as well. So it's very useful for us to develop such kind of solutions in our group plants. Then one point is a worker efficiency. In any of the cement operation, in a technology, available technologies, there is a key role of operators, those who are operating a process. So if you see the process operation of one particular operator in particular shift, he is having a one set of mind who can make his logic to control the process. And in the second shift, the other operator is having a different logic to control the same process if same condition arise into the process operations. So with the help of digital tools, we could able to analyze transparently all the operators' manual actions, and we could work it out who has given a best control to get a good result out of it. So we can educate other operators or train other operators if such condition arise into the operations, how efficiently you have to take action into it. So these tools help us a lot to get a transparency on the operations. Then definitely the bottlenecking into our operations, we could able to very proactively get the predictive analysis of assets, any anomalies and all those things that we can very priorly get alerts and all those things. So those systems we had implemented in our digital tools. So we can timely address those assets, not switch into the failures. We can take a proactive actions to get rectify it, or if it is a problem is not tolerable, then we can take a scheduled downtime and address those things and safeguard our assets into the bad damages and all these things. So these are the maintenance and all those things. These help us to optimize our maintenance cost, downtime reductions and all those things. Few of the use cases I could able to explain you in our group plants. So these are the unique installations we carried out in our group plant premises, which has been abandoned for a long period. Like wherever we are exploring a limestone for our cement plant, there we get a query, and those queries filled up with the water, and that we are using as a water harvesting and utilizing for our plant utilities. But alternately, we had used those assets by putting an installation of solar on it and getting a power generations. So these are the unique things we have done in our group plants, most of the locations. And one more example, in our cement plant premises, we have a space constraint over there. By considering a power requirement of this particular plant, in a very small area, we have installed a higher capacities and getting a higher generation out of it. So in general roof mount solar plants, for 1 megawatt installations, there is a requirement of around 2.75 to 3 acre of land to install a 1 megawatt of power, PV solar power. But here, in a 8 acre of land, we have installed 5 megawatt of plant by taking a unique design of east-west, like a Hutman design, and we get a 4.5 to 5 megawatt power generation within that area and contributing to our plant operations. And these all assets we are digitally monitoring its operations, its performance, and with some advanced tools, we could able to analyze the forecasting of our power generation, our operations anomalies, like in cement plants. Of course, in cement plants, we are all the strict follower of all CBCB guidelines and all those things. But within cement plant premises, there is some cement dust. And those are very harmful for solars, specifically for PV modules. So if it contacts with the moisture or water, it creates a very hard coating on the modules. So those analysis and these things, we are very closely monitoring by implementing a digital tool. We have made a very digital twin process into the system of our solar plant operation, like our cement plant process and all those things. And we are closely monitoring all anomaly detections, soiling impact, equipment efficiencies, any equipment health conditions, and even the performance of plant. And over and above, we are forecasting the next day generation as well, and we are getting a almost same result what we are forecasted. So that could help us for our business plannings, day-to-day business plannings and overall business plannings. So in our digital tool, which we had implemented and accessible on mobile as well as on web, so these are the performance monitoring tools we have invented our systems. So all the SCADA system of our solar plants, the key parameters we fetched onto the cloud with the diode technology of knowledge lens technology which we had implemented. And that data we had fetched and developed a customized dashboards for all levels. At user levels, we have implemented one dashboards. For middle management, we have created and prepared dashboards. For senior managements also, we have developed. So senior management and middle management have access to all group plants. They can access on a single mobile app. Whereas user levels, access is given for the particular plants. So we could able to monitor all the equipment's health, all inverter level, string level performance of individual plants we could able to monitor. Whatever anomalies we are detecting on any of the equipments, operations and all those, so we have done some SMS, email alert notification as well. We have prepared a escalation matrix we have developed in association with Knowledge Lens expert team. If any of the equipment or any of the process is giving some anomalies or it is going beyond that, so at any hierarchy level, it will be giving alerts to address those things prior to failure of that equipment. So it helps us to very closely monitor these things in a parallel way. Then this MIS reporting as per our management requirements and all those things, we have customizedly developed those things in our tools. Over and above these artificial intelligence and machine learning tools, we have implemented in our process. These examples we are giving for the solar, the same we are implementing into the cement operations, thermal operations, WHRS operations as well. So we could able to analyze the efficiency of individual modules, individual strings, and individual inverter level as well. If any of the inverters or strings is underperforming due to soiling or any of the electrical fault or anything, so timely it will be getting a alert to us, and our O&M team members can timely address those things. So we are not landing into the energy loss. All system losses on different levels we could able to see into our systems. All MPPT levels of the inverters, we can compare the performance MPPT level for particular inverters, for multiple inverters, and all those things. There is a tool we have developed to get the equipment's preventive predictive maintenance framework and planning based on the performance and all these. Weather forecasting, whatever sensors we have implemented in our solar plants, those data we are fetching into the Knowledge Lens cloud, and based on these historical data and real-time data, we could able to forecast the tomorrow's weather as well. And based on that, we could able to analyze what will be the expected generation tomorrow will be getting, what will be the irradiation trend we are getting in a past days, and what will be the tomorrow's. So these help us to make our business plan or our next day planning for the utilization of energy from the renewable sources. Of course, this solar generation, forecasting and all those things, system degradation also we could able to analyze with these tools. These are the dashboards which I am displaying here. We have developed for these things the day-wise dashboards, how we are monitoring the KPIs, these individual sensors of temperatures, irradiation parameters, its individual sensors readings, its average out values, its cumulative values, all these we are monitoring in a mobile instantly for all the plants. These are few of the trends where we can monitor the string level, inverter level performance of individual inverters. We can analyze and compare with the past data as well. What will be the performance on that particular weather conditions of that particular inverter, and what will be the present performance of these inverters, and accordingly we can take actions on it. These are the day-wise dashboards where we could summarize our yesterday's generation, today's generations, what will be the yesterday's performance level, what is a month-wise performance we had achieved, what is yearly performance achieved, all those things, what will be our targets, that targets we are getting based on the design part, and the performance forecasting also we are setting up our targets, and we are getting our operations performance accordingly. All these are the dashboards where we can monitor all our KPIs, and you can see the actual irradiation and forecasted irradiation. There is a slight difference. So whatever historical data it is means accommodating to us, will be getting a very precise result towards the forecasting and actual with these tools. This preventive energy loss in solar farms, in solar plants or any of the process operations, there is a key challenges to minimize the energy loss, because few of the losses which are not foreseen, sudden downtime of any of the equipments may lead to the dim generation, because our planning we are making in a such a way that in daytime where our sunny hours solar generation is there, so we can consume the maximum generation of solar into our process and minimize our conventional generation which we are taking from other sources of power like grid power, thermal powers, and other sources of powers. So imbalancing these things, if any of our batch process get down or sudden breakdown happens, so this solar generation in generation hours will get into the dim generation, and that is a huge loss for any of the organization. So we are, by closely monitoring in total aspects, cement operations, cement equipment health, as well as our other supporting sources of powers and all those things, we are balancing in such a way that to utilize maximum renewable powers or low cost power into our systems and optimize the conventional or high cost power to the system and get the efficient productivity of any of the process. So these are the key challenges highlighted here. Our utilities also, we are focused on the utilities, our water consumptions, and these things into our solar maintenance part. We have introduced a dry type robotics into our systems to optimize our water consumption into the solar plant maintenance. So when our dust falling on the solar plants in a dry condition, there itself we can, with the robotic cleanings, we can clean those dust and minimize the water consumption, to use a water for deep cleaning of the modules and all those things. Yeah, okay. Okay, okay. Okay. So these are the key implemented on all aspects, we get it done. Root cause analysis, energy losses, proactive alerts, and all those things. And these are the energy generation forecasting tools, all those things which we had implemented. In cement plants also, as I told you, these are the key challenges, how to minimize the downtime of cement plant operations, unforeseen downtimes. So for that also, these digital tools help us to improve our performance of the equipments and minimize the downtimes. These are some of the dashboards we are displaying here for these things. And we are into the emission, means we are focusing on the emission control as well towards sustainability. Those parts also we had very closely monitoring in our group plants, and meet out all the CBCB guidelines, and over and above in our upcoming projects, we are implementing a very high efficiency or high efficiency equipments to meet out our CBCB guidelines and reduce the dust emissions and all. As per CBCB guidelines, there is in cement plants, there is a targets to uh, get a pollution of 25 micrograms in overall, and all AQMS and all those things, if it goes beyond that, it will be getting alerts. But we had designed our equipments in a plant such a way that, so we have take our internal targets to get the maximum 10 milligrams emission from our particular plants. This way we have designed our equipments into the cement plants. Of course, we are contributing towards the carbon footprints minimizing by using of fossil fuels, then renewable energies, and alternate fuels into our process operations and all, and reducing of carbon footprints as well. This knowledge lens is, we had associated and partnering with the knowledge lens, and I am very thankful to the knowledge lens expertise team who has supported us to implemented this digital solution for the Dalmia group. So these are the their solutions available for the industries, so which we had already adopted, and they are having a expertise and domain expertise also to get a good solution to the industries. Thanks from my side.